বাসা স্যার কথা শুনতে পাচ্ছেন?
স্যার আমি শুনতে পাচ্ছি কথা। তানভীর ভাই জয়েন করছে দেখলাম।
হ্যাঁ,
তানভীর
পাঠান
ভাই
তো।
জয়েন করছে।
হ্যাঁ,
আসসালামু
তানভীর
আলাইকুম।
ওয়ালাইকুম আসসালাম।
তানভীর তানভীর ভাই তো কালকে ডে ডিউটিতে করছে মনে হয় সব কাজ।
না, সব করতে পারিনি।
বাসা স্যার লিখতেছে জয়েন প্লিজ। বাসা স্যার তো নাই, টিচারই তো নাই।
ইনশাআল্লাহ।
হোয়ার ইজ মিস্টার মিসাইল ম্যাডাম, মিশেল ম্যাডাম সরি।
মিস সাইদ ম্যাডাম। আর পোলাপান কই? অনুপম কই? তারপরে ওই যে চাইনিজ সিয়া।
স্যার রেকর্ডিং হচ্ছে কিন্তু।
হুম। রাশেদুল ভাই জয়েন করছেন।
Hello, I hope you all are doing great. Let's start our today's session and let me know if there is anything which you guys are confused about regarding our session. By the way, let me also know about my voice quality and the network, if it's fine or not.
No ma'am, everything is fine.
Okay, that's great. Uh, do you guys have any questions regarding our last session or any confusion regarding it? Okay, I think that there are none. All right. So we were at our feature engineering step. First, there was data exploratory analysis, then feature engineering. And after feature engineering, we will move towards the training part. Like we will apply different algorithms then. Right now, it's feature engineering. And we discussed there that we are at the step of transformation, feature transformation. And then what did we do? We covered handling missing values. So there were few options, imputation, CCA, we covered them all. Now the next step is to handle categorical variables. Like we have categorical values in our data. We have some alphabets there, textual data there. So we need to handle it first because if we will feed our data to the model as it will give us error because it is unable to understand it. So the very first thing we need to do, we need to convert the textual data into numerical data, and then we can feed it to the model. So let's first see how many types of data are there and how we can handle them. I'm going to share my screen and there you guys can see it. By the way, I have already shared it. You guys must know about that one. Okay, so yeah, it's feature engineering. that one. Okay. Encoding categorical variables. The very first thing, how many types of data do we have? We have numeric data, we have categorical data. Just take the example of the Titanic data set. So in that one, we have age column. That one is the numerical column. And then we can have some other column where we have, let's say, class. That in which class the passenger was sitting. So maybe it is first class, like it is written as first, FIRST, then second class, then third class. Okay. So here we have different categories. It is not in numerical format. Or maybe we can take some other data set where we have categorical data. Maybe we have employees information, and there we have their educational background. Like this one has done masters, this one has done PhD. So like there we will have different categories. So there are two types of variables, basically numeric and categorical. So where we are having numerical data, there we have further two options, continuous or discrete. Now the difference in between them, that in discrete we will have a specific number of uh, a specific limit of numbers, and these numbers will get repeat in that column. But when it comes to continuous numbers, they are changing for each sample. It is something like this. For example, we are taking the price column of the houses. So the prices are changing for each sample. But let's take another numerical column, which is, let's suppose, number of rooms in the house. So there we have a limit, like it will be in between 1 to 10. So there we have limited numbers which are getting repeated, but in when it comes to price, um, it is continuous in nature. And how do we decide by ourselves? We set some sort of threshold, like if there are different numbers more than 10, then we will consider it continuous, otherwise we will consider it discrete. So it depends on us. On the basis of the data, we decide what sort of column we will consider continuous and what sort of column we will consider discrete. Okay. So that's for numerical. Let me know if there is anything which you just don't understand. Now come towards the categorical column. There we have further two types. One is ordinal, other one is nominal. Now I'll give you two examples. Uh, the same one, educational background of the employee, bachelor's degree, master's degree, PhD. And then there is another column where we have information about what? Hmm. About the eye color of the employee, let's suppose. Okay, it is something which is not making sense, like why we are having eye color in the column, but let's just take it for an example. Here we have red, green, sorry, black, gray, green, brown. These sort of colors are there. Okay. Now, ordinal, nominal. In ordinal features, categorical features, we have some sort of order, like one is better than the other. There is a specific order. For example, bachelor's degree, then comes master's degree, and then comes PhD degree. So there is a hierarchy. So it is ordinal in nature. But when it comes to nominal, then there is no such order. When it comes to eye color, there is no such order that is better than other, or there is certain type of hierarchy there, like green, black, brown, whatsoever it is. So that's the difference between them. Now, why we are covering it here, that when we are going to convert them into numerical data, for ordinal ones, we want to capture that order too. If there is order in the hierarchy, we want to capture that order too when we have converted it into numbers. But for nominal, there is no such order. We can apply some other techniques in which order is not retained, because actually there is no such order. So we can apply those techniques then. So first we need to see if it is ordinal in nature or it is nominal in nature. Any confusion up till now? Just let me know. Okay, so it's all clear. Ordinal, nominal, and then there is label encoding. We will discuss it later. Like, what's label encoding? Here we are having an example: poor, good, very good, excellent. Like, these are the ratings of a movie, maybe, or some restaurant: poor, good, very good, excellent. So it is ordinal in nature. Now, how we can do the conversion? We can consider like poor is 1, good is 2, very good is 3, excellent is 4. So there is a certain order in the numbers also. So the order we were having here, we are retaining it here. Now, when it comes to nominal, let's take the example of nominal here. Like, we are having different animals in the column: dog, cat, sheep, horse, lion. There is no such hierarchy. So saying dog as 1, cat as 2, that's not a good way. When we will train our model, it will consider, okay, dog is 1 and cat is 2. Maybe cat is somewhat more important. It has a higher number. Maybe I need to capture this pattern also. But that is not the case. That's why we need some technique which will not make it ordinal or create some sort of order there. So then comes one hot encoding. In one hot encoding, what becomes like, here we are having different categories: dog, cat, sheep. First, we will convert them into separate columns. Okay. So these different categories, we will convert them into columns itself. So the dog, here we are having it as a separate column. Cat, here we are having it as a separate column. Same goes for other animals: sheep, lion, horse. Now what we will do, if for the first sample we are having dog, then we will consider it 1, and for all others it will be 0 in the data. Now here we are having cat. So just for cat, we will say it as 1. And for all other features or columns, we will consider it as 0. So that's how we are converting this information into numbers, but there is no such order like one is better than other, or there is some sort of hierarchy, but still we are able to capture it. Is it all understandable? Like, or there is any confusion?
Why do we need it, madam?
Why do we need it? Actually, we need to do the conversion because our models are unable to understand. For example, when we will train a model, let's suppose to do the prediction of stocks. In stocks data, we have some categorical columns. When we will feed it to the model to do the prediction, it will give us an error that I am unable to understand that specific column. that specific information inside the column, because models can just work with numerical data. They can deal with textual data, or they cannot deal with imagery data, they cannot deal with audio data. Whatsoever data it is, we need to convert it into numbers. We need to convert images into numbers. We need to convert text into numbers and audio data into numbers so that models or systems can understand them.
And then should we convert all the categorical columns to numbers, numerical
Exactly.
columns?
Numerical columns are already numbers,
No,
and we need to convert categorical columns into numbers. Yeah.
yes, I'm saying that. Okay, thank you.
Yeah, we need to convert them. Otherwise, model won't be able to process it. So different types of categories for different types of columns, either ordinal or nominal. So the technique's name is one hot encoding. Why it is one hot? Because there will be just one at a single place. So it is one hot and all others are zero. One. Here if we will see, one is just at a single place and all other columns are zeros. Okay. By the way, there are different drawbacks of different categories also. For example, if we will apply this one hot encoding technique on a column where we have many categories, like 20, 30 categories. Previously, we were able to feed our data in a lesser space, but when we will have 20, 30 categories, then we will consider each category as a separate column. So instead of one column, now we will have 30 separate columns. So the space it will take, it will be 30 times more than the original. And the time it will take to process, it will be a lot more. So in those cases, it is not a good technique. Like it will take a lot more space, a lot more processing time. So then we have some other techniques also in order to do this conversion, but right now we are just covering the basic ones, like how we can do it. So yeah, that's the most basic one hot encoding. If you guys are understanding this thing, like why does it take more space, more memory, and processing time too? Because this one column has converted into 5 different columns, and information is just here. There is no information here in these columns, so it is just taking some unnecessary space. Oh, sorry. Okay. Here it is. Now let's see how we can apply it. I am going to share a notebook. Is it visible, the notebook? I think it's visible. Okay. And there are two ways of applying one hot encoding. One through the pandas library and another one is through the scikit-learn library. We will see how we can apply it on both the cases. Now let's have a look at this data set. We are having this cars data set. We have the brand, then we have the kilometers that are driven, the fuel, owner, selling price. So here this one is a numerical column and kilometer driven. This one is a numerical column. Other three, they are categorical in nature. So our model won't be able to understand them. Then we need to decide which ones are nominal and which ones are ordinal in nature. So first owner, second owner, third owner, it seems like categorical in ordinal in nature. Then fuel, I think fuel is just nominal in nature. Like that's some characteristic. What do you guys think? Like we can't say that diesel is better than petrol. It's some fuel which the vehicle is using. So it's nominal in nature. We don't need to capture any order there. And then for brand too, I don't think there is a need to capture any sort of order. So we can consider it nominal in that case. Okay. So here we are just checking the basic information. Then yeah, we can convert it using pandas and scikit-learn. In pandas, there is a function named as get dummies. With the help of it, we can do the conversion into one hot encoding. Now we will have different columns instead of different categories in a single column. So we are applying this function on these two columns, fuel and owner. Okay, maybe we should just consider fuel, not owner. And here, what information do we have? Here we have brand, kilometer driven, selling price as it is. After it, we had this fuel column. So now it is adding the categories with the fuel. We have a category CNG. So now there is a column named as fuel CNG. Then we have a category named as diesel. So it is adding these both, fuel diesel. Then fuel LPG, fuel petrol, and like this. So we are having these four columns for fuel. And for owner, what do we have? We have owner, first owner, then we have owner, fourth and above owner, second owner, owner, test drive car, and what else information do we have? Third owner. Okay, there we have such information too. So that's how we have done the conversion, and right now we are having information as false and true. The false will be considered as 0, true will be considered as 1. So true will be just at a single place and all others will be false. So that's how we do this conversion. Okay. And now there is this one thing, like there is a parameter which is known as drop first. What does that mean? Just to make you guys understand. Okay, I have written it here. For example, there is a column gender. Here we have two genders, male and female. There is no hierarchy in them. We don't need to consider any order. It's ordinal, it's nominal in nature. Now let's suppose we need to do its conversion. If I am going to convert it like this, 0, 1, like the first sample is female, so it's 1. Just don't consider this third category for now. Male, female. First sample is female, so here we have written it as 1. This one is 0. Second sample, second person is male, so it is 1. This one is 0. And let's suppose the third one is a female, so this one here we are having 0, here we are having 1. Now we are having these two columns. If I will drop the first column like this, I am going to drop it. If we will be able to identify that whether the person is a male or a female just with the help of this column, if we will drop the first column, whether our model will be able to do the identification with the help of just this column. What do you guys think? Dropping the first column is any sort of loss or not?
No loss, madam.
No loss? Yeah, because we are able to identify still that the first person is female, the second person is not female, that's a male, third person, it's a female. It means we can drop the first column. And it is just the first column in case of multiple categories also. So there we have this parameter named as drop first. If we will consider it true, it will drop the first column. If we will consider it by default, it's false. It will not drop the first column. So, but if we will make it true, it will drop the first column. So now for the fuel, it has dropped a column. Previously, we had 4 categories like diesel, LPG, petrol, and CNG. Now we have made it true, so we don't have CNG now. Maybe here we have false for any. Okay, these ones, none of them are for CNG. By the way, you guys must have got the idea. Now we don't have CNG, and if there is any sample where all of these 3 are false, it means that was the CNG one. Same goes for this one. Here we are having 4th and above, second owner, test car drive, third owner. We have dropped the first owner information. All of these are false. It means this car is of the first owner. It has first owner information in it. This one is for the second owner, and likewise. So it's just about this parameter. By the way, it doesn't make any major difference. It is just used to drop first column or not. Now we can do the same thing with the help of scikit-learn. In scikit-learn, we have this function named as one hot encoding. The technique's name is same as it is. It's one hot encoding, and we need to import it first. So here we are importing it, one hot encoder from sklearn.preprocessing, like we did it for imputation. From there we imputed the simple imputer from sklearn, and here we are importing one hot encoder. Now how we can apply it? Same steps. We need to make its object first. So we need to mention these parentheses inside it. If there are any uh, parameters which we need to mention, we will mention them, and then we will apply it. So here we are mentioning the drop first thing. Do we need to drop it or not? Sparse output, D type, it will be integer in nature. By the way, if we will not mention them, that's also fine. We can just apply it as it is. That's our one hot encoder, OHE. We are applying fit transform function then. And then we are mentioning on which columns do we need to apply it. After it, on test data, we just need to transform. And yeah, we can have our new data like this. So it's 1 0 0 0 like this. We are having it. So that's how we can apply it using scikit-learn, and that get dummies function It was for pandas. Okay, that's our data. Hmm. Here we are applying it on brands column, but if we will see, we are having various categories here, and we can check it by in unique or with the help of value counts how many different categories are there. So in total there are 32 brands, and we discussed an issue with OHG that if there are more categories into a single column, it will make them separate columns, and then it will take a lot more space, it will take a lot more time to process. So that's an issue. So here we are having 32 different categories, and if we will notice, here we have checked the value counts. We are having 2448 samples of Maruti. We have 1415 samples of Hyundai, and same goes for other brands. And then there are few samples which are from these categories, like these ones. These are really few samples. If we will consider them, it will not make any bigger difference, but it will take a lot more time, a lot more space if we will convert them into separate columns. So what we can do, we can consider a specific threshold. Like if there is a specific category for which we are having lesser than that specific number of samples, then just drop it. Like for this cars data set, if for a specific company I have just 10 samples, then just drop it, because that lesser information, it will not help me in training the model. It will just increase uh, the memory it will take, and it, like, the processing time will increase, so we can just drop them. So here we will consider a specific threshold. Here we have considered it 100. Like if the number of rows are lesser than 100, then just drop it. So which ones will get drop in that case? Yeah, after this one we will drop all others. By the way, we can make it 10 also, 50 also, whatsoever it is. And now they are a lot less. How many are remained? Yeah, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just 12. Instead of 32, now we are having 12 different categories in our data. That's how we handle rare categories also. Okay, any questions? Okay, there aren't any questions. Now let's cover ordinal.
I have one question.
Yeah.
When we will use index, uh, uh, um, earlier you have seen cat dog, that time there is indexing, but
Mm-hmm.
in this case we can see only a true false. I understand true means 1 and false means 0, but
Hmm.
how will use this indexing? It is not shown here because
Could you
there
please
is
repeat
a five.
your question?
There are 5 type of animals.
Hmm.
1, 0, 1, 2, 3, 4. But
Hmm.
when you consider this one present, that time this one, and
Hmm.
uh, left is 0. but we have to mention this one, this indexing. Where we will put this indexing?
We are mentioning the sample numbers.
Sample number.
Yeah, we are capturing those sample numbers. Like they have their index information. For example, this one has index value 4831. Index shows how many for example, if I'm having 6000 samples, it will start, index will start from 0 and index will end at 6000. It will start
Okay,
from 0 and it should end at 5999. Yeah, index always starts from 0. And how many samples do we have like this? So that index is the sample number. So we are mentioning it here, like count those ones which are having lesser than that specific threshold. We are capturing their indexes and then we are replacing them from uncommon. That is some other thing that I will make you understand. Okay. Okay, cover this point also. By the way, you have understood about the index thing, why we are capturing index?
yes, now I understand.
Okay, that thing is clear. I missed this point. Let's cover it here. Now, the point is when we are dropping these ones, like the Nissan or these ones, it means we are losing lots of data. 81 these samples, 71 these ones. So there will be a lot of data at the end which we will lose. What we can do, we can make a single column for all of them. For example, rare cars. We can consider it as rare cars column. So if it is a Jaguar, we will consider that it is from rare cars column. So the rare car column will be 1 and all others will be 0. If it is a Jeep, we will consider it a rare car. So it will be 1 and all others will be 0. So we are retaining all the samples still, but it is not taking that many space, or it is not taking that many time to process. Are you getting this point? So what we have done here, we have captured the index and then we replaced them with uncommon, or we can name this column anything like the rare cars or any other thing. So here we have mentioned an uncommon column. If any car belongs to that specific category, then it will be true here and all others will be false. So that's how we somehow retain that information regarding the rare samples. Is it understandable or does it make any sense? Actually, it is always like we need to maintain a balance between the accuracy of our model and the processing time and the memory it is taking. So it is always this balance. If it is really very accurate, but it is taking a lot of time, then our client or our user, it will not wait that much. Like when we are using some sort of application, for example ChatGPT, maybe it is really accurate but it is taking 5 minutes to respond, we are not going to have that much patience, or we are not going to wait for it to respond to us. So we need to maintain that balance. Also, it is very expensive if it is taking a lot more time. So we need to maintain that balance. Maybe a system which is not giving us 100% correct results, rather it is giving us 95% correct results, but it is giving us answer instantly, we will prefer that one. So here maybe by replacing it with this single column instead of those other 10-20 columns, we will make it a lot faster, but it will not be that much accurate. So yeah, that's a balance which we need to keep. By the way, if this point is understandable, if you guys don't understand it, then just let me know. Otherwise, we will discuss it a bit more. Or at least just confirm it in the chat that you guys are understanding it. And I was about to discuss the other technique, which was ordinal. All right, the process is same for ordinal as it was for one hot encoder. We need to import it from scikit-learn sklearn.preprocessing. After it, we will make its object and then we will apply that fit transform function like we did it for one hot encoder. Here we are having this data set. Now this one column, city column, it's nominal in nature. There is no hierarchy. Cuff, I think it has information it like if it is mild or it is very strong cough. So that's some hierarchy in it. Because on it the thing depends whether the person will have COVID or not. So there is some hierarchy. If the person is not experiencing any sort of cough, maybe the person won't have COVID. Maybe there is some relation in them. So there is this hierarchy here. Then comes gender column. There is no hierarchy there. So we can consider it nominal. So maybe on gender and city column, we can apply one hot encoding, and on cuff column, we need to apply ordinal encoding. Now, maybe any one of you wondered, like we have this column also has COVID, and there we have this categorical information, yes or no. We need to do the conversion for this one also. At this point, we will discuss that label encoder, which we discussed before here in the slides. This one, that we have ordinal encoding, nominal encoding, and then the label encoding. The output feature is known as the label. If we need to do the conversion for that label, then neither we apply one hot encoding nor we apply ordinal encoding. For this one, scikit-learn has introduced a separate encoder which is known as label encoder, which is specifically for output column. And with the help of that one, we will do the conversion for the output column. So we will apply label encoder on has COVID column, nominal on city and gender, and ordinal encoder on cuff column. Now, when we are going to apply encoder on cuff column, then we need to mention its hierarchy also. So here it is ordinal encoder, we are making its object. There are these two categories there, mild and strong. Here we need to mention it in the specific order. If we will mention strong first, then it will give strong as 0 and mild as 1. If we will, so the weaker one to one, we need to give a lesser number, we consider it first. So we want mild to have a lesser number. So that's why we are considering it first. And same goes for other data set. Maybe in employee data set, we have the educational background. There we have bachelor's degree, master's degree, PhD. So first we will write bachelor's. then the master's, and then the PhD. So in that same way, it is going to assign them different numbers. So first mild, then strong. And after it, we will apply fit transform method. And that's how we can do the conversion. And if I will show you, yeah, this is how it will look like. It will have information like this. For mild, it will be 0. For strong, it will be 1. Like that sort of information it is. And now all the data, it is in numerical format. This is for the ordinal one. For label encoder, the process is same. We will import a label encoder for that one. I will see where I have imported label encoder. To do the conversion for has COVID. Okay, I have not applied it here. I will open some other notebook where I can show you how to apply label encoder. Yeah, here it is. So we need to import it from sklearn.preprocessing label encoder. We need to make its object, and then we will apply it on our output column. We keep the output column information into the Y. That's why we have mentioned Y train here. And then the classes were before yes and no. It will get convert into ones and zeros like this. Label encoder dot fit. And that's how we can do the conversion with the help of label encoder. Any confusion in encoding, just tell me now. Is there any confusion in encoding? Mr. Fazle, Mamin, Mehdi, Mansoor, there isn't any confusion? Okay, then maybe we can just stop it then. Okay, we'll see you guys in our next session then if you guys are just done with it.
One hot encoding and the second one that should be applied for X-train X test, and label encoding should be applied for Y train one Y test.
Okay, let me show you again. It is not like X-train X test as a whole. I will share my screen. It is for individual columns. When we are going to apply encoding, it will be for individual columns. These columns are there. Let's suppose age, gender, review, education, purchase, whatsoever it is. What is our output column? Which one of you asked the question?
Me, madam, Shoykot.
Okay, all right. So could you please tell me that which one is the output column in this data set?
Purchased.
Purchase. Exactly. That one is the output column. So what we will do when we are going to split our data set into train and test, first we need to see which one is the output column, which ones are the input column. So in X, we will keep all our input columns. In Y, we will keep our target column or the output column. So here we will have purchased, and here we will have all of them: age, gender, review, and education, like this. Okay, that's how it will be. After it, we know that we need to split them into train and test. So we will have X train, X test, Y train, Y test. So 70% of these columns will be in X train and 30% will be in X test of these columns. Then 70% of the output samples will be in Y train and 30% will be in Y test. Is it clear up till now?
Yes, madam.
Okay. When we are going to perform the conversion, then we don't need to perform it on age column. We don't need to encode it. We need to do the encoding for gender, review, and education. So we will not apply encoding on the whole X or X train. We will apply it on these individual columns. When it comes to Y, we just have a single column in it. There is just a single column. So if we need to apply it on output column, we can apply it on Y train or Y column. Like this, because it is just a single column. And that's why we did it like this. If you will notice it here, we are applying the train test split. We have our training data. And here we kept review and education. By the way, where is the other one? Okay, so we kept here, we are applying this iloc function and we are considering just these three columns here. We will discuss it later, how does iloc works. But right now we have minimized our data set and we are considering these three columns here: review, education, and purchased. Now we are dealing with them. So whenever we need to apply encoding technique, we apply it on the basis of columns, column wise. It is not like X train or Y train. In the Y train, we just have a single column. That's why we are applying it on Y train as a whole. So here we are considering categories: poor, average, good, and school, UG, PG, how many categories or lists we are, we will mention it there. In both these, we need to apply the nominal encoding, one hot encoding. No, we need to apply ordinal encoding in both of them. So we will create a separate list for them. There was a single column, and it was which one? There we have this. It was review. In review, we have these three different categories: poor, average, good. So we have mentioned these three different categories in the specific order. Then we need to apply it on the education column also. We have these three categories there: school, UG, PG. So we have mentioned these three categories also. Now we can apply this conversion. We have applied fit method here on xtrain. On xtrain we have just these two columns, that's why we are applying it on the whole xtrain. Otherwise we would pick each column one by one, and we have applied it then. Here we have applied it. This is our ordinal encoder, and when we will apply transform method, then it will transform them into numbers. So this one is the review column, this one is the education column. Here we have 0, 1, 2 numbers: 0 for the school, then 1 for the UG, and then for PG. And same goes for reviews: poor, average, good. We have 0, 1, 2 like this. And if we are going to cover label encoder, we are applying it on train, because in train why train? We just have the output column which is purchased, I think. Yeah, that output column purchased. So we are applying on it. And initially the categories were, if we want to check like what were the original categories, so we can use this classes method, and it will tell us that there are just these two categories, no and yes, and we have converted them into numbers. Any confusion now? Is it clear? Maybe if you guys are speaking, then I am unable to listen, or maybe you guys are just not speaking.
No, madam.
Okay. If still there is any confusion, you can just ask and I will try to handle it.
Madam, we should practice, and then we can inform you if is there any question in the next class.
Okay. All right. Yeah. Just do some practice and let me know if there is any confusion regarding it. And we will discuss it then.
Okay.
And then Mahdi, is it clear? Mr. Mahdi? I don't know how to pronounce it. Maybe Mehdi or Mahdi. Okay. All right. We'll see you guys then. Bye-bye.
Okay, ma'am, it's okay. I think.